Okay, our final question for homework 1 is a spherical shell of uniform thermal conductivity has an inner radii of 1 meter and the other radii of 2 meters. At 1 meter, the temperature is 100 degrees Celsius, while at the outer surface r equals 2 meters, the temperature is 0. What is the temperature at radius 1.5? Oops. Okay. So let me fix this quick. I just realized I messed this up. It's supposed to be 1.5. Okay, so I have our diagram set up. I have our spherical shell. That is going to be symmetrical, so the only thing that's going to change temperature is going to be the radius. So since everything's symmetrical, only the radius is or only temperature is going to change with radius. And we have R naught, here we have, or the outer surface, we have 2 meters and 0 degrees Celsius. And at the inner circle shell, we have 1 meter at 100 degrees Celsius. And we're trying to find the temperature here. So it's going to be somewhere in between 0, so we can do RMT is going to be greater than 0 degrees Celsius, but less than 100. So we know that. So we can use that to check our work. And here I just have the equation we're going to use to solve this and integrate, which is 1 over r squared d over r dr times the quantity r squared dt over dr equals 0. So we're going to start integrating that and plug in our value. Okay, so I brought this quantity down. So let's start integrating. So our first integration will just be under what's underlined, so it's going to be r2 dt over dr is equal to c1. And then we want the c1 and the r on the same side, so we're going to put dt dr equals c1 r squared. And then that's going to leave us integrating our final time with time related to radius is equal to negative c1 over r plus c2. Okay, that looks good. And then now we can kind of just use what we know from up here to move on. So let's do at RO and R inner. At R outer we have 2 meters and 0 degrees Celsius. And at radius inner we have 1 and 100. So now we can put this equation in here. So we're gonna have at T2 is going to be equal to negative C1 over 2 plus C2. And here we're going to have T1 is equal to negative C1 over 1 plus C2. Okay, wait. These are not. This is wrong. This should be the temperatures. Not the radius. So this one will be 0. This one will be 100. My mistake. So what we're gonna do is we're gonna solve for C2 here and plug it back into this top equation as a series of equations. So that can go, and then this can be added on that side, so we're going to be left with C1 over 1 is equal to C2. Yeah. Right, C1. Hold on, let me check. Okay, I figured out what I messed up. It was not a mathematical error, it was just me. I flipped these two on accident. So this one should be 1, this one should be 2. So we're going to be left with, okay, good. Still recording. Going to be left with C1 over 2 is C2. So then we can plug this in up here and solve for C1. So let's switch back to black. So we're going to have 100 is equal to negative C1. We don't have to write everyone. C1 plus C2, which is C1 over 2. Okay, we got that. So, how would we solve this? Multiply by 2, but then we'd be left with 0. Let me check. Okay, so this would be 100 equal to negative C1, I said chlorine, C1 over 2, and then just multiplying by 2, we would get 200. Cool. And then we can plug it back into this equation up here. To show what C2 is, so we would have 0 is equal to, we would have 0 is equal to C1, which is 200. Oh, well, this would be negative, and this would also be negative, but so it would make it positive. Over 2 plus C2, so we would have C2 is equal to 100. Okay, cool. Now we can use our values in this. I'm going to copy this down to find our new value. So we know C1 and we know C2, and we know the radius too. So let's do it. So our radius is 1.5 meters. So we're going to have negative 1.5, C1 is 200, and 100, oops, this will just be positive, because of the negative. Okay, so I don't have a calculator. I don't think there's a calculator app either. I'm just going to, I'll just do the math and be back. Okay, I'm back. This quantity is equal to 133.3 repeating. And then I originally had a plus 100 here, but then I went back because I knew the value had to be in between 0 and 100, so I knew this was incorrect, so I checked. And I just forgot when solving for C2 here, you're going to have to subtract C2 over to get 100, so it'd be C2 is equal to negative 100, so that's a negative. So 133.33 minus 100. Our temperature of our midpoint is going to be equal to, not 133, 33.3 repeating degrees Celsius.